Here we'll summarize the cosine rule, sine rule, and area of a triangle rule. We'll look at the formula, we'll look at when we use it, and we'll have a look at a quick image of an example of something where we might use it. So first of all, the cosine rule for lengths is a squared equals b squared plus c squared minus 2bc cos a. Now when we use this is when we're finding a length, we know the other two lengths and the angle that is opposite the length we're trying to find. What this means in practicality is we have two sides and the included angle. So an example might be a triangle like this, where we know this is 11, this is 8, and this is 37 degrees. And we would be finding this length here, which I will call A, to match up. In this case, this angle is A, and these are B and C. Doesn't matter which one is which. The important thing is we have two sides and the angle between them. In general, we might have something that looks like we know this, we know this, we know this, and we want that. The cosine rule for angles is just a rearrangement of this formula, which is cos A is equal to b squared plus c squared minus a squared over 2bc. We use this when we know A, B, and C, the lowercase ones, so that's when we know all three sides. So an example might be something like, we've got 15, 12, and 7, and we want to find one of the angles. So we want to find this angle here. In general, we've got our triangle. What we have is three sides, and we want to find one angle. Now, the only important thing is the angle here is opposite this value here. So this edge here is going to be this edge here. So in this case, 7 would be A, but these two are interchangeable. Now let's have a look at the sine rule. First of all for lengths, and then for angles. The sine rule is A over sine A equals B over sine B equals C over sine C. So this says the ratio of an edge divided by sine of the opposite angle is constant no matter which pair we choose. So in this case, we're looking for two angles and any side. And it really can be any side, although it might not immediately be obvious that we can do that. Perhaps, for example, we have our triangle that looks like this. We have that length is 8, this length is 30, and this length is 40. What we're trying to find is another side. Now, in general, to apply the sine rule, we're looking for pairs of opposite sides and lengths. So if we're trying to find a length, we have an angle and a length, an angle and the other length is what we want to find. But because we know two angles here, we can always calculate the third angle if we need that to be the opposite one. So in this example, we didn't have the thing opposite 8, but we can easily find that angle because it's angles in a triangle. And then we have the angle opposite 8. And if we're trying to find this one, we would be using the 30. If we were trying to use this one, we would be using the 40. We're looking for two angles, one side opposite one of those angles and the other side opposite. The sine rule for angles is very, very similar. It is just the reciprocal of this formula. And now this is the one that you are not explicitly given in the formula booklet, but it is just the reciprocal of the one above. So hopefully you can see that that's easy enough to work out. And we use this one when we have two sides and a non-included angle. If we have the included angle, we would use the cosine rule. So what this might look like is something like this, our triangle. We have two sides and the non-included angle. And notice again, we've got those opposite things going on. We've got 35 and 5 and 7, and what that means is this is the angle we can calculate in this case because it's the one opposite the 7. So we're looking for those pairs of opposites. So again, in our general case, we've got our triangle. What we would have is one angle. We would have the length opposite that angle. And if we have this length here, that means we can find this angle here, the opposite one to the length that we know. The sine rule is always about opposite angles and lengths. You need two pairs of opposites. In both cases, you need two pairs of opposites. And one of those four things we don't know. The final formula in trigonometry that we need to be able to use is the area of a triangle. The area is equal to a half AB sine C. And to do this, we need exactly the same as the cosine rule for lengths, which is two sides and an included angle. So this might be something like, we know this length is 11, this length is 8, and this length is 37 degrees. And we could calculate the area. In general, we've got our triangle. We need two lengths and the angle between them. If we have that, then we can calculate the area of that triangle using this formula.